we're going to get going on this notes/worksheet here. This thing is not too challenging, but it does give you a good intro into what calculus can do for you. So let's go ahead and get going here. You should have the worksheet already on your screen beside this and kind of work with me throughout this. And there'll be parts you'll have to come back to and finish because I won't do every piece of it for you here. But you can go ahead and work along with me here. We'll do about half of the worksheet today, and then we'll do the other half tomorrow. So again, let's get going. The scenario for this one is Mr. Hyman and Mr. Ayers take that trip, and we're going to Georgia, and our distance equation is right here. The d of t equals 595 t squared over 8.5 plus t squared. So we've got that equation to work with, and question number one simply says, okay, find the total distance traveled for the trip. Well, if you look up in the paragraph here, it says it was a 9.5-hour drive. So to get the total distance, it's as easy as going ahead and doing d of 9.5. And you guys will have to excuse me on my technology here. It's pretty weak today because our smart notebook is not working at the high school. So I'll have to get that fixed for the next one. But anywho, we're going ahead and doing 9.5 in for t, do a bunch of calculating, which I have mine, and you should too. I have mine in my, I can't see it here because there we go. I have mine loaded in the calculator. So I just put the equation in, and I used this window 0 to 10. Since the trip took 9.5 hours, I went ahead and went to 10 hours. And then I went 0 to 700. Now, the reason I chose 700 is just, well, I know Georgia's about, I don't know, 600, 700, 800 miles away. So I went ahead and just chose 700, and it made a pretty decent window for the graph. You can see the trip, throughout the 10 hours. So as far as doing D of 9.5, this is nothing new to you here. I'm just going to hit trace 9.5. Obviously, I could have went to table and looked at 9.5, but my Y value is right there, 543.785. So 543.785. And you should start carrying 3 decimal places because you're in calculus now. The AP Calc exam requires you to carry 3 decimal places on problems like this. So get used to it. You might as well do it now. All right. So there's number one. Number two says describe how their velocity changes over the course of the trip. Then compare their average velocity for the first 4 hours to the last 4 hours to confirm your results. So looking at this graph right here, I would definitely say the first 4 hours, it looks like they covered a lot more distance, because distance is the Y value, than they did in the last 4 hours of the trip. So I'm going to say they were a lot faster in the first 4 hours. And then let's go ahead and back that up with a little calculation here. Now, the calculation we need to do here is just simply a slope calculation, because distance divided by time, well, that gives you velocity. And it's also y over x is slope. So velocity is going to be equal to slope for this graph. And that's true for any distance time graph. The slope is going to be a velocity. So you're learning calculus right now. So let's go ahead and do the first 4 hours of the trip. So to do the first 4 hours of the trip, I'm going to go ahead and do, sorry, I got to look at my notes here so I can see it. I'm going to do D of 0 because that's when the trip started. And if I put 0 into this equation right here, the top would be 0, the bottom would be 8.5. 0 divided by 8.5 is 0. I mean, you can put that into your calculator if you want to, but I don't think you need to. All right, so there's my D of 0, and I'm going to go ahead, it said first 4 hours, so I'm going to do D of 4. And going to the graph, I went ahead and did this earlier. It comes out to 388.571 miles is where we're at 4 hours into the trip. All right, so using these two pieces of information right here, these 2 points, so I got 0, 0, and then 4, 388. I'm just going to find the slope between those 2 points, and that's just a matter of y2 minus y1 over x2 minus x1. So I'm going to go ahead and do slope for these, and so I'm taking 388.571 minus 0 divided by 4 minus 0, and I get my slope is an incredibly fast 97.143, and that would be miles per hour. So apparently, Mr. Ayers and I rented a Ferrari to go to Georgia here. So, anywho, going pretty fast in those first 4 hours. That's our average speed in the first 4 hours. My goodness. Nobody stopped to pee there, did we? All right, so there's the first 4 hours. I'll let you guys do the second part of this problem on your own. It just asks you to do the last 4 hours. Just to remind you, you'll be doing 5.5 to 9.5. So you're going to do D of, I guess I'll start it with you a little bit. You're going to do D of 5.5, get that answer, and then you're also going to have to do D of 9.5, get that answer, and then just do the slope between those two. All right, so I'll let you guys finish that one. And I will tell you, just to warn you, because I thought I missed it when I did it earlier. I'm like, what? That's no way. We ran into some heavy traffic towards the end of the trip. It's very slow average speed the last 4 hours of the trip. So don't let that fool you. It's a little under 20 miles per hour, just to let you know. All right, so number 3 here. Let's go on to this one. This one asks, on which of the following intervals does Mr. Ayers drive the fastest? Would he ever be speeding? Mr. Hindman would never speed, of course. All right, so we're going from the time interval of 1 to 3. Now, don't let this notation get to you. That should not be something that makes you go, what in the world? That should be, oh, yeah, okay, closed brackets. Yes, this is nothing more than domain right here. They're wanting from the domain, the x values, in this case, time, from exactly 1 to exactly 3, including 1 and 3. That's all that means. So don't let the notation get to you. That's why we did all this pre-calculus stuff, so that you could dominate the calculus. All right, so let's go ahead and do D of 1, and we're going to find out how far we went in the first hour then. And then we're going to do D of 3, find out where we were 3 hours into the trip. And then, of course, we're going to do the slope to this again. So you can, sorry, I can't see again. You can jump onto your graph, hit trace, 1, enter, bam. There's my Y value of 62.631. And then you can do the same thing with 3. And I did it earlier. It comes out a nice even 306. That's kind of nice. And no, just so you know, you don't have to do sig fig stuff. This isn't chemistry. I don't waste your time like your chemistry teacher does. My goodness. All right. Please don't tell her I said that. All right. So, anywho, let's go ahead and do the slope between these 2 points. And that's just a matter of taking the 306 minus the 62.632, and then we divide that by 3 minus 1. All right, so that gives us a crazy speed of 121.684 miles per hour. So I would say Mr. Ayers was speeding a little bit right through there, wouldn't you? All right. I will let you do part B, and you can decide, obviously, which one he's going faster through, from 1 to 3 hours or from 2 to 4 hours. It should come out relatively close just by looking at the graph. 1 to 3, yeah, there's my slope. 2 to 4, my slope's going to be pretty close to the same. So I expect it to come out fairly close to there. I don't know if it'll be faster and slower. I'll let you guys decide that. So you can do B on that one. All right, and number 4, this is the last one we're going to do for the day here. This one will take a little bit of time for you to do. but you can speed it up by cheating and using your graph. I'll show you how. All right, so we're supposed to complete the table for each of these: 3, 4, 4.5, 4.9, 4.999, and then 5, and then find the average speed from this time to 5. So I'll do 3 with you, and I'll do 5 with you. You can do the middle 4 problems. All right, so I'm going to go ahead and put in 3. So I'm going to go here, and I'm going to do, you know what? Let's go to our table this time. And I'm going to go second table set, and I'm going to put my independent variable on ask. That way, the calculator will ask me for the x value. I can put in whatever I want and get the y value. So I'm going to go back to that table now. And now the x values are blank because it's waiting on me to ask for one. So I want 3, I want 4, I want 4.5, and so on and so forth. Okay, and I'll let you finish that out. If I put in 5, though, watch what happens. Oh, I'm sorry, that'll be later. Never mind. So I got my 3 and 5. That's the 2 I'm going to do. Sorry, I'm thinking ahead there. You'll see why I said that in a second. So I'm going to put my 306 here, and 5 gave me a value of, I can't see it anymore, 444.03. Ooh, there we go. All right, and then I'm supposed to find the average speed from 3 to 5 for this part, from t is 3 right here to 5. So I'm going to go ahead and take 306 and the 444.03, subtract them, and I'm going to take 5 minus 3 and subtract those. All right, so on my calculator, I'll show you this one so you can see it. There we go. I'm going to go ahead and take my 444.03 minus my 306, and that's just y2 minus y1, and I'm going to divide that by 5 minus 3, which is 2, so I'm going to divide that by 2, and there is my average speed from 3 to 5 hours, 69.015. All right, so that takes care of that. Now, you can do that from 4 to 5 hours, from 4.5 to 5 hours, 4.9 to 5 hours, and 4.999, or I'm sorry, 4.99 to 5 hours. All right, now when I try to do it at 5 hours, though, something interesting happens. If I try to do this on top of itself, like if I try to find the average speed from 5 hours to 5 hours, well, I'm going to take 444.03 minus 444.03, and then I'm going to divide that by 5 minus 5. Well, that gives me 0 over 0, which is not necessarily undefined. It's actually called indeterminate. 0 over 0 is indeterminate. I can't determine an answer from that. And the reason I can't determine an answer from that is because 5 is on top of 5. I can't figure out a change because it's on top of itself. There is no change going on there. So when I try to do that, I will get 0 over 0, which is indeterminate. All right. That's weird looking, but there's indeterminate is my answer. And that's where you need calculus to come into play. And that's what we're going to do tomorrow. Tomorrow, if you're looking ahead a little bit, I ask you to find a great estimate for the velocity at 5. Not an average velocity. I want the instantaneous velocity at 5. And then I ask you to do that again here on 7 and 8. Find the instantaneous velocity at t equals 6 hours. Well, this is where calculus comes into play. And we're going to cheat the calculus a little bit tomorrow. We're going to use kind of a limit method of finding that derivative. Look at that, all sorts of calculus words coming at you. But we'll really kind of dive into it a little more tomorrow. Today, get kind of the grunt work done, and we'll get into the calculus tomorrow. So make sure you finish B on both 2 and 3, finish the second parts, and then finish this chart right here, and tomorrow we'll come in to number 5. All right, you guys have a great day, and take care of yourselves, take care of your family. God bless.